Hello everyone, welcome to my YouTube channel. So today I am going to discuss an interesting problem from CSIR NET exam, the last CSIR NET exam, and this question is from complex analysis. Okay, so this is a very nice problem, and also if you know the results related to entire functions and if you apply it properly, then you can solve it. Okay, so the question is saying that let f be an entire function such that for every integer k greater or equal to 1 there is an infinite set xk such that f of z equal to 1 by k for all z belongs to xk. Okay, then which of the following statements are necessarily true? This is basically a MSQ problem. Okay, so first thing is that let's try to understand the options. So the first option is that there exists an infinite set x such that fz equal to 0 for all z belongs to x. A priori, if you just see the given condition, then you don't know that whether it is true or false. Okay, and second option is also saying something related to the set fz equal to 0. Okay, so it is saying that so if there exists z belongs to c such that fz equal to 0, that means for second option 2 becomes correct, right? Why? Because we know since entire function itself is continuous, then x is basically f inverse 0, right? So that means f inverse 0, that means x is closed. And if x is non-empty, that means there exists some z such that fz equal to 0, then we are done, right? So that means if second statement is true, then I need to check whether there exists at least one z such that fz equal to 0. Now come to the third one. So a priori first two options are not clear yet, that whether it always exists or not from the given condition, right? Now come to the third one. The set xk is unbounded for each k greater or equal to 1. So what is the set xk? So xk is z belongs to c such that f of z equal to 1 by k, right? So xk is infinite from given condition, right? And if xk is bounded, that means there exists a convergent sequence, right, in xk. So xk is an infinite set, bounded infinite set, so there exists a convergence sequence, right, such that xn converges to some point a. Then f of xn converges to some point f of a, and f of xn is 1 by k, that will imply f of a equal to 1 by k, right? Fine. But in that case, if you consider gz equal to fz minus 1 by k, then xn belongs to 0 set of g and xn converges to a, that means a is a limit point of zc, right? And since f is entire, that will imply g is also entire, and a is a limit point of z of c, right? So that will imply by identity theorem gz equal to 0 identically. That will imply fz equal to 1 by k. Fz is constant. Then the given condition is false, right? Because it is saying that for every k there exist infinite subsets such that f of z equal to 1 by k for all z belongs to xk, right? So that means it cannot be constant. So C is wrong. Now fourth one, if there exists a bounded sequence zk such that zk belongs to xk, then f has a 0. So let Zn be a bounded sequence such that for each n greater or equal to 1, Zn belongs to xn. So that will imply f of Zn equal to 1 by n, right? So now Zn is a bounded sequence. So then by Bolzano stress, Zn has a convergence subsequence, say Znk converges to some point z. Then f of Znk converges to f of z, and f of Znk is 1 by nk. So 1 by nk is converges to z. Now 1 by n tends to 0 as n tends to infinity. So this will imply fz equal to 0. This will imply f as a 0. So that means fourth one is also correct, right? Now for first one and second one, you need to check, for second one you need to check that whether there exists at least one z such that fz equal to 0. So what do you think? Is it true that there is if a entire function satisfy this condition, then there is always a point such that this is 0? Obviously not, because you can take your known entire function. What is the best known entire function except the, say, polynomial? So that is e power z, right? E power z, right? So now if you take say for each k, for each k, if you take 2n pi I minus ln k, okay, these points for all n, say greater or equal to 1, what do you get? E power, this is same as e power 2 pi in dot e power minus ln k. This will imply 1 by k, right? Right? So that means, and e power z has no 0. E power z has no 0. So that means you can construct function such that it has no 0. So that then obviously question 1 and option 1 and 2 are false, right? So that means only third and fourth one are correct. Yeah, I hope it is clear to all of you. Thank you.